Hello, my little mathematicians. I'm going to help you finish off the study guide. Remember, always pause the video, try it yourself, and then unpause it to come back to see how you did. Okay, and you can always fast forward to just the one that you needed help on. Okay, so for number 15, you want to find the GCF of 36 and 54. So the greatest common factor. You could list out all the factors, so like 1 times 36 and 2 goes into that 18 times and so on and keep going, and then find all the factors of 54 and list those, and then find the greatest one that they share. Or you could do what you're going to see me doing, the ladder method. That's the one that I prefer. Okay, so you ask yourself, what can go into both 36 and 54? I see 9, and 9 goes into 36 4 times, and 9 goes into 54 6 times. And then are you done, or can anything go into 4 and 6? 2 can go into 4 and 6. And 2 goes into 4 twice, yes, and 2 goes into 6 3 times. Can you keep going? Nope. So then what's your GCF? Just the factors along the side, right? So 18 is the greatest factor that can go into both 36 and 54. And how you can check that you're right is these have nothing in common. And when you multiply this times this, you should get that. And this times this should give you that. 18 times 2 is 36, and 18 times 3 is 54. So that's the greatest factor that can go into both 36 and 54. Okay, 12 and 48. Ready, set, go. Okay, well, I saw 4. If you started with something different, that's fine. You could have started with 3 or with 6 or with 2. You know what? Don't erase your tree. See if we still get the same answer. Okay, 4 goes into 12 3 times. 4 goes into 48 12 times. Can I keep going? Yep. Don't forget about 3. Everyone forgets about 3. 3 can go into both numbers because 3 goes into 3 once and 3 goes into 12 4 times. Can anything other than 1 go into both 1 and 4? Nope. So this is your GCF. Remember, we multiply, not add, because they're factors. Factor means it multiplies to become that number. Well, 3 times 4 is 12. And double check. 12 times 1 is 12, and 12 times 4 is 48. So yes, 12 can evenly go into both, and that was the greatest number because these share nothing else in common. Okay, for the LCM, you could, just like we could list all of the factors, I could list all the multiples of 56. So 1 times 56 is obviously 56. And then if you do 56 times 2, okay, you would type that into your calculator to see what you get. And you get 112. And then you do 56 times 3, and you get 168, and so on. Okay, and then for 72, obviously 72 times 1 is 72. 72 times 2 is 144, and so on. And you'd keep multiplying them out until you get a multiple that they both share. And they will end up sharing a lot, but you want to find the first one that they share because it's the least one. That can take a long time sometimes, right? So again, you're going to see me do the ladder method. And I asked myself, what can go into both 56 and 72? Well, 56 times 72, or sorry, not 56 times 72. What can go into both? I see an 8. Okay, 8 can go into 56 7 times, and 8 can go into 72 9 times. Can anything go into both 7 and 9? Nope, so I'm done. If I was asked to find the GCF, it would be 8. But I'm asked to find the LCM, so I can do this all along the outside, the L for LCM, and just multiply those together. 8 times 7 times 9. Well, 8 times 7 is 56, and then you have 56 times 9, and you get 504. So my LCM is 504. That's the first number that both 56 and 72 can multiply to become. Now for this one, okay, you could list out all the factors again, right? Like 20, and then 40, and then 60, and then 80, and so on. And then here you have 40, and then 80, and then 120, and so on. You'd keep going. Okay, 60, and then 120, and then 180, and so on. You'd keep going until you find the smallest thing that they all share. right? So that's one way you could do it. Or I like to do the ladder. The only thing that's different is when you have 3 numbers, you have to do 2 ladders. So I'm going to do one ladder for these first 2 numbers, 20 and 40. And then I'm going to do a second ladder of whatever answer I get here, that's going to go here, and then with the third number that hasn't been used yet. Okay, so I mean, not that bad. As we established, ladders are pretty easy, right? So let's do it of the first 2 numbers. What can go into both 20 and 40? Okay, 2. And 2 goes into 20 10 times, and 2 goes into 40 20 times. And what can go into both 10 and 20? 10 can. And 10 goes into 10 once, and 10 goes into 20 twice. Nothing can go into both 1 and 2 other than 1. So multiply along the outside to get your LCM, and you get 2 times 10 times 1 times 2. Well, 20 times 2 is 40. And then you're like, oh, duh. Obviously, they both can become 40 because 40 times 1 is 40 and 20 times 2 is 40. Okay, so that is the LCM of both of those. Now I'm going to do it with the third one I haven't used yet. So 20 can go into both of those. 20 goes into 40 twice, and 20 goes into 60 3 times. Now nothing can go into both 2 and 3, so go ahead and do your L for LCM and multiply all those. 20 times 2 times 3. Well, 3 times 2 is 6. 6 times 20 is 120. So the smallest number they all can multiply to become is 120, which if you see, had I kept going with this list, 20, 40, 60, 80, 120, that can become 120, that can become 120, and that can become 120. That's the first number that they all can become. But again, you could have gotten there with a ladder. It's just you need to do a double ladder if there's 3 of them. Okay. Our next one says Lana needs to order supplies for the upcoming month. Her supplier sells pencils in boxes of 12 and folders in boxes of 15. What is the least number of boxes of each supply item that Lana could order so that she has the same number of each item delivered? Okay, so I want to have the same number of each item delivered, and they come in boxes of 12 and 15. So 12 and 15. 12 is talking about the pencils, and 15 is talking about the folders. Okay. What can go into both 12 and 15? Yeah, 3 can. So 3 goes into 12 4 times, and 3 goes into 15 5 times. Can I keep going? No. So for this one, I don't want to order 3 boxes. It's not like a GCF type problem, because I want to get the number of boxes so that I have the same number of each item. So right here, if I did 3 boxes, each box would have like 4 pencils and 5 folders in it, right? Like in the groups. But I want to order boxes so that I have the same number of pencils and the same number of folders. So that's what can they both become, or what can they both multiply to become, which sounds like, yeah, you're right, LCM. Okay, so if I multiply all those, 3 times 4 times 5, well, 3 times 4 is 12, 12 times 5 is 60. So that means I could have 60 pencils and 60 folders. But how many boxes of each do I need to order then, so that then I have 60 pencils and 60 folders? Okay, so I'm going to have 60 of each item. And if I'm figuring out for pencils, okay, I want 60 pencils, but how many come in a box? 12. So what's 60 divided by 12? 5. So you need 5 boxes of the pencils. And then again, I want 60 folders because you want to have the same of each item. And folders come in boxes of 15. So if I do 60 divided by 15, I get 4. So I want to order 4 boxes of the folders. Do you notice something cool? Like for this one, there's the 5 and there's the 4. It just happens. But I mean, I would do it this way, like just in case. So again, if you did 5 times 12, you get 60 pencils. If you do 4 boxes with 15 each, 4 times 15 is 60 folders. So now you have the same amount of each item. You have 60 pencils and 60 folders, as long as I order 5 boxes of the pencils and 4 boxes of the folders. Okay, only 2 more. Let's see if we got these ones right. It says Sarah has 16 red flowers and 24 yellow flowers. She wants to make bouquets with the same number of each color flower in each bouquet. Okay, so like, again, we're wanting to make identical things, so we're going to do my ladder. What can go into both 16 and 24? 4. And 4 goes into 16 how many times? 4 times. And 4 goes into 24 how many times? 6 times. Again, why am I starting to do this? Because I'm trying to split it up in equal groups, so I have to see like what can divide into it, right? So that's why I'm doing my ladder to find the factors and stuff. And what can go into 4 and 6? 2. And 2 goes into 4 2 times. And 2 goes into 6 3 times. Can I keep going? Nope. Okay, so is this an LCM or is it a GCF? Well, it says you don't necessarily have to have the same like number of red flowers and yellow flowers, but you do want them each bouquet to be identical. So I just want to know what's the most number of like bouquets that I can make. So that's a GCF, which 4 times 2 gives me 8. So I'm going to have 8 total bouquets, and then I want each bouquet to be identical. So how many red flowers are there going to be? Well, 16 was talking about the red flowers, and 24 was talking about the yellow flowers. So you're going to have how many red flowers in each bouquet? Hopefully you said 2 red flowers. Now, why does that work? Because if there's 8 bouquets and you only have 16 red flowers, well, 16 divided by 8 is 2, right? So then how many yellow flowers? Okay, well, how many total yellow flowers do you have? 24. And you have 8 bouquets, so how many times does 8 go into 24? 3 times. So you're going to have 3 yellow flowers in each bouquet. Do you want to know something cool? Look at this. 24 is talking about the yellow, so 3 yellow flowers. 16 is talking about the red, so 2 red flowers. Because here's your GCF, right? 8 times 2 gives you 16, and 8 times 3 gives you 24. And so the number right beneath it, that's what tells you how many you're going to have for each of those. That's different from this one. I couldn't, technically you're like, well, then shouldn't there be 4 boxes of pencils, Miss Love? I wasn't talking about like 3 groups, right? If I had 3 groups, then yes, there'd be 4 pencils in each group and 5 folders in each group. But I didn't want that. I wanted to have the same number of pencils and folders. So I had 60 pencils and 60 folders. And so then I needed to do something a little bit different. I just took the total and divided it by how many I had. Okay. Last one. It says a train arrives at the station every 15 minutes. Another train arrives at the station every 20 minutes. After how many minutes will 2 trains arrive at the station at the same time? What do you think? Well, one arrives every 15 minutes, so 15 minutes will pass, it'll come, and then another 15 minutes, and then another 15 minutes, right? Okay, the other train leaves every 20, and then after another 20 minutes, and then after another 20 minutes. So I want to know when's the first time they both will happen. So like I would have to like list all my multiples, right? So this is an LCM problem. So if I couldn't figure it out by listing my multiples, let's go ahead and do my little ladder. What can go into 15 and 20? 5 can. And 5 goes into 15 3 times. And 5 goes into 20 4 times. Okay, can I keep going? Nope. So do your L for LCM. Because think about it. If I were to like, is this a GCF? Is it 5? After 5 minutes, they'll both arrive at the same time. How? This arrives every 15 minutes and this arrives every 20 minutes. Like that doesn't even make sense. But if I did LCM, 5 times 3 times 4, well, 4 times 3 is 12 and 12 times 5 is 60. So after 60 minutes, they'll arrive at the same time. And then you're like, oh yeah, had I just continued this list, added another 15 minutes, I would have gotten 60. So 60 is the first number that they can both multiply to become. So after how many minutes? 60 minutes. Done. All right. Hopefully you did pretty well. If not, go ahead and try some more similar problems to these. You're going to do great. I have the utmost faith in you guys.